So this is chapter 6, again focusing on brittle deformation. So first off, let's define it. What do we mean by brittle deformation? Well, things breaking, bonds breaking, things shattering, cracking, faulting. It's not elastic, it cannot go back, it's not plastic. You get multiple pieces after you have brittle deformation. Table 6.1, page 115 on your book is going to give you a list of terms. Look at them just to make sure you're familiar with them, and then I'll of course cover many of the most prominent ones in lecture today. So brittle deformation, defined as permanent change due to growth and or sliding of fractures. And a fracture defined as a surface of discontinuity. So if you have a nice continuous crystal and then you break the atomic structure so that now it's non-continuous and you have two pieces, even if they're still touching, they're not molecularly and atomically connected to each other, it's a discontinuity. If you have a rock, if you have a boulder, if you have a mountain, any size object that you're dealing with, if it's broken so it's no longer continuous, even if it's stuck back together, it's a surface of discontinuity, and therefore it's a fracture. You could take the two pieces and separate them. So in rock, we can see it like this. A lot of times the fractures then get weathered because water runs into the fracture and weathers it and enlarges it. And so you can see in this rock lots of places where there were fractures that are heavily weathered. Sometimes the fracture is going to fill with something. Makes sense? We call this a vein. Veins can be gorgeous. You know, you have a rock like this, a nice dark mafic rock, and it's got a bunch of white lines in it. Sometimes very random orientations, sometimes odd shapes, sometimes parallel to each other, crisscrossing, all kinds of different patterns. And it can be really, really pretty, sometimes desirable for decorative purposes. Those are called veins. Those were places where that rock was originally solid and black. It was fractured under stress, then later transported by water. Minerals got into those cracks and were deposited and built up and filled them in. On the other hand, if instead of a mineral filling it in, so like those white cracks were a solid single mineral, if it's filled with rock, we call it a dike. This is rock that came from somewhere else, came in as a melt, as magma. Pressure drove it in through the crack, and there it solidified into rock. That's a dike. If it's totally horizontal, it's called a sill. It's effectively the same exact thing. It was just a horizontal crack. The magma went in, solidified. So a dike and a sill, the only real difference is the dike is at some angle and cutting across beds. A sill is horizontal, or at least was horizontal at the time of deposition, and goes between beds. Now, joints. Not something we smoke. This is different kind of joints. Geology's got lots of cool terms that sound exotic, you know, joints and cleavage and acid, and but we use them very differently. So we're not talking about anything that you smoke here. We're talking about big cracks in rock. We have some giant vertical joints here in this big road cut, and they're caused by stress, but there's no displacement. At a distance, you may or may not be able to see the cracks, but the layers of rock look fine. As you get closer, you notice, wow, this rock is full of cracks, but there was no movement. Does have to be natural, so if it's caused by human activity, it isn't really a joint. And joints are often also called cracks or tensile fractures. That's kind of important, specifically tensile fractures, because with a tensile fracture, you don't get displacement. Shear fractures are caused when you have shear stress and there is displacement. This is the first stage of faulting, often called microfaults or shear fractures. They have displacement. For example, here you can see the most prominent is this thin white layer, and it's been displaced. Across that crack, it doesn't line up anymore. A fault is a larger version of a shear fracture, and again, noticeable displacement. So this is a road cut. You can see that lighter brownish colored bed or layer cut diagonally from the bottom left to the top right, and the left hand block, the hanging wall in this case, has moved upward relative to the block on the bottom right, the footwall. Hopefully everybody remembers the hanging wall, footwall terms from their intro class. But just as a reminder, a footwall is always under the fault. So, if you think of the fault plane as like a big surface, the footwall is underneath. You could walk on it with your feet. The hanging wall is above the fault. And, if you grabbed a hold of it with your hands, you could hang from it if the footwall were missing.